So thank you everyone for being here at Cloudburst. I hope you enjoyed the conference. I know I did. So thank you, of course, to the sponsors, to the organizers, and for everyone for being here. So I'm Eldert Grootenboer. Today I'm going to talk about the latest and greatest from Azure Service Bus. But first, quick introduction. So Magnus already told a bit about me, but yeah, so I'm Eldert Grootenboer. I used to live in the Netherlands. I moved to Canada when I joined Microsoft back in February. I'm the program manager for Azure Service Bus. If you have any questions, any remarks, you can always reach out to me. And with that, let's start the session. So what can you expect today? So what we are going to do is first we start with a quick introduction into Service Bus, just so everyone knows like what is this and when should I use this. Then we are going to go over the recent releases. So we just had Ignite about 2 weeks ago, so we are going over what we actually released at Ignite. Then we are going to look at what is coming soon. So this is about the next 3 months or so, these things will be dropping. And then we are actually going to have a bit of a look on the roadmap. So what are we thinking of? Do we have envisioned coming forward? And finally, with all of these, I will also tell a bit about the background, like why did we build it this way? What are the choices that we made? Why are we doing the things the way we do? So with that, let's first do a quick introduction in Service Bus. So who here is already using Service Bus? Quite a few people, good. So Azure Service Bus. So Azure Service Bus is a platform as a service queue and pops up message broker. So we do queues and pops up. So queues is basically I put something in, consumer picks it up, and that's it. Pops up means I put something in, I can have one or multiple subscriptions, I might have filters on those subscriptions, and I can actually have my consumers listen to different subscriptions. So for example, I might have a subscription for West Europe and North America. And then depending on where the message needs to go, by which system needs to be processed, we'll actually go to one of those subscriptions. Azure Service Bus is fully managed. So we fully manage this for you. So it's PaaS service. So you just think about your solution. You don't think about all the infrastructure, etc. You just think about what you want to accomplish. We have support for AMQP 1.0 and JMS 2.0. And so this JMS is the Java messaging service, of course. So if you are using, for example, IBM MQ or ActiveMQ or something else that talks to JMS, you can actually very easily switch it out by just changing your connection string, importing a package, and that's about it. Yeah, of course, AMQP support. So if you already are using anything that's using AMQP, you can also very easily switch. Service Bus also has polyglot Azure SDK. So we have different languages that we support. Of course, .NET, but also Java, Python, JavaScript, Go, and probably some others. We want to run cross-platform, so we make sure that your applications can run cross-platform. We are inclusive. We want to make sure that you can use your tools, your environments. And we have industry-leading reliability and availability. So officially, our SLA is 3 nines. In practice, we see 5 nines or 6 nines to ours internally. And when I say internally, that means that for our customers, they actually get more availability. Because if you use our SDKs, we have things like retries, etc. built in. So in practice, our customers would normally see about 8 nines or 9 nines on availability. So very available. And of course, we integrate with other Azure services. So we have bindings for functions, we have connectors for logic apps, and we make it very easy to consume and produce messages within different services for Service Bus. So if you look at the tiers, we have basically 3 tiers. So we have the basic tier, maybe some kind of development. We don't really have that much users on there, so we will not talk about that too much. But the basic tier just has queues and schedule messages. So then we have the standard tier, and so most of our customers are on the standard tier or premium tier. So standard tier is pay as you go. So you pay per 10,000 messages, you pay for your actions, but you only pay for what you use. Now, what's important here to note is that there's messaging capabilities that we have. So of course, queues and topics. So queues where you put something in, you retrieve something, topics, so that pops up. We have schedule messages, transaction support, duplication of messages, sessions. So you can actually have a single consumer that reads all the messages with the same session ID. So that way you can make sure that those messages are always processed in order. You can forward to and send via, and our message size is 256 KB there. So this is really your, I just want to use something that I can very easily spin up, I pay as I go, etc. The downside of standard is that you're using shared hardware or shared resource, I should say. So what that means is if you are on a cluster that has another very, how do you say, another customer that's doing a lot of loads, you might get impacted by that. So your messages might, for example, all of a sudden take 1 second instead of 50 milliseconds. Now, this for many of our customers is okay, like they don't need that like constant latency. But if you do need that constant latency and that low latency, you should be on premium. So that's very important there. So on premium, you pay per hour. So you don't pay per message, but you actually pay per hour or per month for most of our customers because they just are running production, so they're not switching this off. But you can actually switch it off, for example, for a development environment, and you'll just get billed per hour. And of course, you get everything that you get in standard. But on top of that, you also get some other things. First of all, you get a message size of 100 megabytes. Now, if your messages are 100 megabytes and you need more, please look at your architecture because you're probably not doing messaging at that point. You also get that resource isolation, which is very important, like I said, because that actually gives you your dedicated resources. So we do this per MU, messaging unit, and a messaging unit gets a certain amount of CPU and memory. And that is specifically reserved for you, so no one else can touch that. So that also means that you will always have this available, so you always have the same latency, the same throughput, etc. We have GeoDR, so geodata replication. There is still this asterisk there, that we are going to talk about later. So at the moment, you only do metadata data replication. So basically your infrastructure, your queues, topics, subscriptions. But more on that in just a minute. JMS 2.0 support, which we already discussed. And finally, we have availability zone support as well. At the moment, not all regions, but we are working on getting this to all regions where we have availability zones in Azure. So that should also hit soon. We are part of the Azure Messaging team. So Azure Messaging basically consists of 3 parts. So first we have Service Bus, what we are going to talk about today. And so Service Bus is a pool-style queue-based transfer of jobs and control via message queues and topics. So let's see what we are saying here. First of all, pool style. So the producer pushes something in, the consumer pulls it out. So the consumer is in control of getting those messages out. So that also means that consumer can process these messages in their own tempo. It's queue-based, so with queues and topics, we already discussed those, but yeah, so it's queue-based. And what you're doing is jobs and control via messages. And so a message is something that you want to happen. You are telling to another system, you might not know which system, but you know there's another system out there that's going to do something for you. So you might say something like, do a calculation for me, create an invoice, ship this order. But you are telling someone else, another system, like, go do this for me. Like you have an intent there. So that's Service Bus. Then we have Event Hubs. So Event Hubs is a partitioned, high volume, tape drive style, sequential recording, and unlimited pool style rereads of event streams. Once again, let's break it down. So first of all, it's partitioned. So you have different partitions, and so your messages go to different partitions unless you specify a partition key. But in general, normally, like your messages are just distributed across those partitions, which also means that you don't have that guaranteed order. It's a tape drive style sequential recording. So for those that know Kafka, it's very similar to that. But basically what you do, you get a stream of data, so a stream of events. And what you can do over those events is, of course, you can play them back, but you can also go back in time. So if, for example, you set your retention to 7 days, you can actually go back to 7 days back and actually reread those messages or those events. And I'm saying events here, so that's different from messages. So events is actually something has happened. I want to notify something has happened. I'm not telling someone to do anything, but someone might be interested. So that's what you use this for, so that event of streams. Once again, also pool style based, so also the consumer is in control of getting that. And also, next to AMQP and web services, this also supports the Kafka protocol. So if you have Kafka, you can basically just change your connection string to event hubs, and it will just continue working. And at that point, you don't have to manage your whole Kafka environment, etc. And then third one, event grid. So as the name suggests, also about events, also about those, like something happened. But where event hubs is about a stream of events, so something that probably correlates together. Event grid is about discrete events. So something has happened, it's not directly correlated to another event, but I want to notify someone about this. So in this case, it's push style distribution. So push, the producer pushes something in, but event grid pushes it out. So event grid is in control of actually getting this out to our consumers. So unlike the other two, where it's actually consumers in control, but with event grid, you just get it pushed to you. And we see this mostly in services workloads. Also because of the push-push, you need to have something that's scalable. So serverless really works well with this. And for example, what we see this often is with some blob storage. So you put something on blob storage, event grid gets an event, it pushed out to a function, and then the function starts processing this. And now if I push in one file on blob storage, it will just spin up one function. If I push 1,000,000 files on blob storage, it will spin up more functions, start processing, and when they're done, they scale down again and they're done. So let's have a look at the recent releases. And so like I said, we just had Ignite. So this is mostly what we released, or this is actually what we released at Ignite. And the first one is the minim TLS picker. So this has gone GA, which means it's now fully supported. And what you can do with the minim TLS picker is set your minim TLS version. So for those that have worked with Service Bus before, you probably know that we used to have TLS 1.0. You could get minim TLS 1.2, but you had to actually put in a support request, and then we would manually move your namespace to a different cluster where we had TLS 1.2 configured. Now you can do this yourself, just on namespace creation or on configuration. So at any point, you can now change your minim TLS version. And so if a connection comes in with the lower TLS version, so let's say you specify this on 1.2, someone comes in with TLS 1.0, we will just drop the connection. So this really makes your environment much safer. Also, we are now doing TLS 1.2 by default. So of course, if you're using Portal to create your namespace, then you will probably just pick this. It will be the way 1.2 by default. But for example, if you do this to Bicep or ARM templates, if you don't specify a version, we actually push this into 1.2. So we always give the highest limit now. And this was released for Service Bus and Event Hubs. And many of you will probably not know, but Service Bus and Event Hubs actually share quite a bit of architecture and code, like the code. So it's actually quite a few of these platform things. So not like the specific messaging or event stuff, but the platform stuff, the infrastructure stuff. You'll often see this coming both the Event Hubs and Service Bus, just because you share so much architecture, etc. So that's the first one. Second one, Service Bus Explorer. And so anyone that has worked with Service Bus probably knows the Service Bus Explorer standalone tool. It was created by Paolo Salvatori, maintained by the community together with Paolo. And Service Bus Explorer is a great tool. It still is, don't get me wrong. But we had a couple of customers that were asking like, hey, we need something that's supported by Microsoft because this is a standalone tool. We do not get any support. So we want something that is maintained by Microsoft and we can get support on. Also, they were saying like the standalone tool is nice, but not if you're on Linux or macOS because it's Windows only. So they want something they could use on their machine, no matter if this was macOS, Windows, Linux, whatever. So what we did is we actually integrated this in the portal. So if you go to a queue, a topic, or a subscription, you will see this Service Bus Explorer icon over there. And if you click on it, you will load this view. And here you can actually send messages, receive messages, speak messages, and do a lot of operations on them. You can resend the message, like you can change it, etc. So basically, we have a lot of that stuff that we have in a standalone tool, we have now in the portal as well. It's integrated with Azure AD, which was also something that we did not have with the standalone tool. So you always had your SES tokens enabled. A lot of our customers don't want to have those SES tokens enabled. They just want to use Azure AD. So you can actually disable the local authentication. So you can just use Azure AD. And now with this Service Bus Explorer, it's actually integrated with Azure AD. At this moment, though, you do need data owner permissions on the namespace. We are working on that, so I will tell more about that later on as well. So it implements most used features on the standalone tool. We definitely don't have everything there yet. Like there's a lot of stuff that's still in the standalone tool that we don't have. But we do want to go forward with implementing more of those features. So if you have input like what you want to see, please let us know. And those new features will be introduced gradually. So this is now GA, but it's definitely not finished. Then the third one, or actually third and fourth one, I should say, because it's actually two features, but we are shipping them together. And this is now a public preview. And actually, this is at this moment still behind the magic link, so you will not see this yet. If you want to start using this, please let me know, because I can give you the magic link and get you onboarded on this. It should go in complete public preview very soon, though. It's already deployed in, I think, Northern Europe and somewhere West US, I think. We are deploying in more regions as we go, and we will remove that feature flag very soon, so everyone can start testing this. So first of all, scaling partitions. So scaling partitions introduces the concept of partitioning on Service Bus Premium. We already have this on Service Bus Standard, but it works differently. So what you will do on Premium is, during your creation of your namespace, you will specify the number of partitions. So at the moment, you can have either one partition, so no partitioning, two partitions, or four partitions. And what will happen is that this will give you much more scalability, because at this moment, you could only go from 1 to 16 messaging units. With partitions, you can get the same amount of messaging units per partition. So that means if you create 4 partitions, you can go up to 64 messaging units. Now, we have a couple of customers that were asking for this, because 60 message units, they could not, it was not enough for them. They do like thousands or hundreds of thousands of messages per second. So they really need that very high throughput. So that's why we created this. And what you will do is, once you set a number of partitions, that will also be your minimum number of MUs. So if you set 4 partitions, your minimum will be 4 MUs, maximum will be 6 for MUs, and of course you can scale with this as well. So what we actually do in the backend, we have different namespaces basically that we completely abstract away from you. What is important here though is that it really focuses on true high throughput scenarios. So if you really need that high throughput, an absolute order is less important for you. Because what's the same as with event hubs, because you are using partitions, messages will be put on those different partitions. So if you want to have the maximum throughput, you should not care about the order. However, that doesn't mean that you cannot have order anymore. So relative order is still preserved. So within the same partition, the order is preserved. So what you can do is you can specify a partition key, and those messages with the same partition key will always go to the same partition, and then also always be in order. If you want even more control, we still have sessions, of course. We had that. That's still supported on partitions as well. And with sessions, you can actually say not only do those go to the same partition, they will actually be consumed by the same consumer as well. So then you still have your perfect order. Of course, this does have some impact on your performance. So really think about how much performance do I need? How important is my ordering? The second one that I want to show here is local store. And so local store is actually something on infrastructure level. So what we are doing is we are moving to multi-tiered storage. So multi-tiered storage means that we used to have Azure Storage as our backing storage solution. Now, Azure Storage is amazing, but because we are going from Service Bus to Azure Storage means that you have network hubs. We all know when there's network, something can go wrong on network, and we might introduce some more latency. Also, we have a dependency on Azure Storage. So whenever Azure Storage had an issue, and when I'm saying an issue, it might just be like a hiccup of 1 or 2 seconds, but we would have a hiccup of 1 or 2 seconds as well. Our latency is used to be about 50 milliseconds. Now, if there's a network hiccup, that all of a sudden goes for 1 or 2 seconds. Our clients actually notice this. Like we have clients that really need that 50 milliseconds max, and preferably even less. So with the multi-tiered storage, we are now first going to local storage on Service Fabric. So Service Bus is running on Service Fabric. So we first go to local storage, and then we offload on Azure Storage as needed. So this means that we get much more consistent latency, because we don't have those network hubs anymore. We don't have a dependency on a different service. So we have much more consistent latency. Also, we have lower latency because we are now just going local. So we went down from 40 to 50 milliseconds end-to-end to 20 to 30 milliseconds. So also there we see quite nice improvement. And this actually is something that's going to be rolled out for everyone in the end. For now, it's tied in together with scaling partitions. So if you enable scaling partitions, you also get local store. But the second one is actually something that once you go GA, everyone will get this. Also, it vastly improves reliability, and this is also very important. Like I said, Azure Storage has issues, and we have customers that if those messages take 2 or 3 seconds, they actually lose thousands of dollars on money. So that's actually quite important for them. Like we need this consistent low latency. We need it already up, And by removing that extra dependency, we have now less parts that can break. So that's what we recently released. So everyone can start using this. Like I said, if you want to use the scaling partitions and local store, please let me know. I can give you the link for this. And it will be coming in in the portal very soon. Now we are going to see what's coming soon. And so this is actually work that my team is currently working on. That's currently in development. I'm working on the final functional specifications. But this is work that will probably come to into private preview in the next 3 months or so. I do want to say these are preliminary timelines. Like, we are working on this, but we are also all developers, so we know that we might run into some issues. So I'm not making any promises here, but like those 3 months, and I will actually give you a bit more specific dates for each feature. But that's about what we are thinking. But don't come on Twitter like, hey, you promised me this will be on this date. No, there's no promises. We try to hit those dates, but like I said, I'm sharing here this like roadmap stuff, development stuff. Like, we might run into issues, we might run into different priorities, etc. The functional designs are still in design phase, so I'm still working on those. So what I'm going to tell today might change still different. Might still be different. Like, there might be some changes. Don't expect very big changes anymore, but what I'm telling today might still change a bit. And please provide your input. So on the end of the session, I will actually have a QR code that I want you to scan and provide your input for these different things. And also just reach out to me whenever you can. But because we really need your input, because that's why I'd like to do these things, like get the input from the community, from our customers, because in the end, we are building this for you. It's not that we are building this for ourselves, like we want you to use this. So we want to make sure that what we are building is what you can use. So first of all, that letter queue batch delete. The name already kind of implies it. It does delete messages in batches. So what you can do, as it looks now, you will be able to specify batches up to 4,000 messages. And so basically you'll just say, okay, delete the first 4,000 messages from my dead letter queue. We are looking into if we can introduce some kind of filters, but that might be like a second phase that we are going into. So not sure if that will be right now. But this really allows you to do much faster deletes. And this mostly, so we have customers that have like 1 million, 2 million, 10 million messages in their dead letter queue. And what you would do now is actually receive those messages and then like do the receive and delete, but loop through all of them. And that takes a very long time. So they want something that's very faster. And so that's what this gives. Also, because we are going to delete on our sites, on the service side, you don't actually have to receive and delete anymore. You just delete. And so with our first test, we see about 400 to 500% performance improvement due to that. So the first focus is on that letter queue. So most of our customers, when they want to delete messages from their normal queue, like might be a few, if they need to batch delete, they probably just are going to delete the queue and recreate it. So that's why you first focus on that letter queue, because that's actually one that you cannot delete on its own. You will also have to create a normal queue with it. So that's why you are focused on this first. It will be integrated with Service Bus Explorer, so you will probably get a nice button, purge, and then it will probably purge everything. You might be able to specify some filters. But it will also, of course, be integrated there as well. And finally, we are looking into evolving this into a full purge, where you can just say, okay, just purge my entire queue. I don't want to do the loop constantly. Just purge everything for me. The reason why we did not do that yet is due to performance, because as you can imagine, if you have 10 million messages in your queue, it's going to take some while and some like processor power, memory to actually process this and actually delete those. If this is something that you just kick off and as we would have implemented now, it would actually impact your receive and deletes because there's now big workload running there. So that's why we first went with the batches, so that we, as we receive batches, we can actually throttle you on those requests. So that way we make sure that your namespace keeps running. But we are looking into, can we build this further where we can actually give that full purge. So next, durable terminus. And so if anyone here knows AMQP specs, this is actually part of the AMQP spec. So a terminus is the encapsulation of the endpoint state associated with the source and target of messages. So basically on the surface, you have a terminus, and on your client, you have a terminus, and between them, you have a link. And so whenever the link breaks, so for example, your network goes down, your client dies, we do an update on our host, whatever. But if for any reason your link breaks, at this moment you will lose your message logs and session logs. So that means if you're running your messages at this moment and you lose that connection, your message will become available on the queue again and will be picked up by the next consumer. And at that point, you might have two consumers doing the same work on the same message, which you don't want probably. So with durable terminus, actually, before we go there, yeah, so and we see this mostly because of containers. So as with coming of containers, containers are meant to like be able to go away, come up again, etc. Like this is the behavior of a container. So with that, and also with distributed systems, so like things like multi-cloud, edge computing, we also see that those networks are less reliable. So with durable terminus, you actually allow you to recover your broken link. So if the link has broken for any reason, if you come back within a specific time, and at the moment that will probably be 5 minutes, we are still looking in private preview what will be exact number, might be 5 minutes, 10 minutes, something like that. But if you come back within that time, your connection will be restored and will actually get your full message state back again. So your message logs will be there, your session logs, etc. Also, this means currently if you do peak log mode and you want to run more than 5 minutes, you have to do a renew on your log. You have to keep doing this until you're done. With durable terminus, you won't be doing this anymore either. You'll just specify a durable log mode. And at that point, that log is yours, unless, of course, your connection breaks for more than those 5 or 10 minutes. And then third one, geodata replication. So I already mentioned that asterisk that was on the slides over there. So at the moment, we only do metadata replication. We are implementing full geodata replication. So full data replication, all your messages, message state, including all your configuration of your namespaces, so RBAC configuration, VNet configuration, everything will be replicated. And we are going to do this across multiple regions. You can decide which regions. We are going to give you free hand in designing that. Do think about where you are going to do this, especially with the second point. We have strong and eventual consistency. Strong consistency will give you RPO 0. So with strong consistency, what we will do, you have 3 locations, your primary and 2 secondaries. And we are going to do quorum-based commits. So if the primary and at least 1 secondary says, okay, I've committed, then you'll get back to 200 okay. This is very important with those regions because, of course, when we are going to replicate to a region, we have the speed of light, etc. I talked to Microsoft. I'm not allowed to put in RFC to change the speed of light, so we have to deal with this. So I'm not allowed to break the laws of physics. But that means, for example, if you say, okay, my primary region is in West US, one of my secondaries is in North Europe, and one of my secondaries is in Australia, this is going to bring quite a bit of latency. So if you want to have strong consistency, you probably want to have it at least close-ish together. Like you might use paired regions or something like that. But we do let this up to you. Like what we will give you guidance. So in the portal, what we are thinking is probably if you choose a region that's far away, we actually show you, okay, this will be your latency. And that will be both ways, of course, because we are going to replicate it, but also get the okay back from the commit. So we are going to give you some ideas like, okay, if you are going to choose this region, this will be your latency that you're adding here. If you don't care about your RPO that much, like you might have an RPO of 5 minutes or 10 minutes or something like that, you can also use eventual consistency. With eventual consistency, you only need 1 replication, 1 secondary location. And what you are going to do then is as soon as it's committed on the primary location, you get back your 200 okay. And then in the background, we are going to do asynchronous replication. Of course, we are going to keep track of the lag. So for example, if you say an RPO of 5 minutes, we are going to keep track how much lag do we have currently. If we hit 5 minutes, we will start throttling the incoming request because at that moment we cannot guarantee the RPO beyond that anymore. So we will introduce manual failover. We are looking into automatic failover, but that has a lot of caveats that we have to think about. So we'll first go with manual failover. But we do want to give you a lot of indicators around, okay, how is your namespace healthiness? What is your lag between the regions? So we will give you indicators. And with those indicators, you can already build your own, I would say, automated manual failover. So for example, you can set up some alerts, and then that alert might trigger a runbook that will then do the failover for you. So that's what we are looking into now. And also for eventual consistency, like I said, you might, for example, have a lag of 5 minutes. We are going to give catch-up options. So what this will do is you can specify, I want to fail over, but first try for X minutes, 1 minute to to an hour, for example. But I want to try to catch up over X minutes to try to get those messages that are not replicated yet into my secondary before I fail over. Now, you can set this yourself, like you can set it to 0. I just want to fail over now. I don't care about those messages. They can be lost. You can also say I want this for 5 minutes. Then your RTO, of course, will be from plus 5 minutes. The RTO we are looking for is about 1 minute, so internally, and then the extra catch-up latency will get added to that. So that's what we are currently working on. And like I said, this is actually stuff that my team is working on this. We are going to private preview quite soon with this. Actually, I forgot to give the exact dates. So the batch delete will probably be March-ish. The durable terminus will be November, and geodata replication will be January. So as you can see, it's all coming relatively soon. Now for the roadmap, and this will be much longer out. So this might be 3 months up to a year or even 2 years, depending on how things go. So like I said, this is still in very early phase. Like this is just like we are currently thinking about this, making some designs, discussing this, investigating options, etc. So there's no timelines to share yet, and also no promise being made. Like what you might see today might actually not come out in the end. Of course, we want to bring this everything out that I'm talking about here, otherwise I would not be showing this. But things might change, so we might run into circumstances which make us not bring this out. I will be sharing some stuff today, but things will definitely change. Like just because we are now just first on our discovery path, things will definitely change. So, but I'm going to share the ideas that we have at least. And also here, your input is most welcome. Like, please provide that input here as well. So first of all, Service Bus Explorer improvements. So like I said, Service Bus Explorer is now GA in the portal. You can use this, it's supported, but we do want to have more in there. And so the first one that we are working on is granular RBAC permissions. And so granular RBAC permissions will allow you to set permissions on the queue, topic, and subscription level. And also to set permissions that you, for example, can say, I want you to show the message headers, but not the message body. So that's something that you are working closely together with the RBAC team for. And actually the main part there is the subscriptions. So each topic can have up to 2,000 subscriptions. So as you can imagine, that is like grows exponentially. And so with the current implementation on RBAC, we cannot do that on subscription level. So what we are probably going to do is use ABAC. So for those that are working with storage, you might already know this. So attribute-based access control. So what you are going to do is actually set attributes on our subscriptions and allow you to do this as well. Where you can say, okay, I have certain attributes on my subscription, and I'm going to give access based on those attributes. And that's much better scalable than RBAC. So that's what we are looking into now. Also, like I said, what you can do is, for example, say, I only want to give permission to see the message headers, but not the message body. So if you have sensitive content, I was just talking to banks earlier this week, and so they have content, of course, in the message bodies that they don't want to show to their first line support, for example. But they still want the first line support to be able to see, okay, what was my dead letter reason, so that header, and probably to resubmit the message. So we are going to make them much more granular. The second thing we want to do is namespace level browsing. So as I said, at the moment you go to your queue, then you will see the Service Bus Explorer option. But it will only be for that one queue. If you want to watch a different queue, you actually have to go in the portal, go to a different queue, open it up again. So it's like not very fast at the moment. So what we want to do is basically the same as that standalone tool does. Just give you a tree view of all your queues, topics, and subscriptions, and you can very easily switch between those. Now, there's also something that we have to do here first, and this mostly is around actually getting all the different queues, topics, and subscriptions, and actually getting a list back of that. So we are working together with the Resource Explorer team to work on that. And then third one is the standalone Service Bus Explorer. And I know we just brought it into the portal, so now we are so the portal one. What we want to do is also to have the same experience in a standalone experience, because we do still have customers that are saying, well, my first line support should not have access to the Azure portal because they can break things there. So we don't want that, but we still want them to be able to manage those messages. So we have a couple of different IDs here. Like one ID is just a complete standalone tool. Other IDs are integrating this with, for example, Visual Studio Code. So we are investigating options there and moving forward there as well. So that's all on Service Bus Explorer. Next, we have subscription metrics. And so subscription metrics is something that we cannot do today. So we can have metrics on queue or on a topic. On a subscription at this moment is not possible, once again, because of that sheer amount of subscriptions that we have. If we would enable it on subscriptions at the moment, we would basically go over our MDM system. So apparently we are not allowed to do that. So together with the MDM team, so our internal MDM team, to see how we can actually improve their performance and make sure that we can actually do 500 times, 1000 times our current metrics. We're also looking, because that might take a while, so we're also looking into actually doing this with log analytics. So Event Hubs already does this. Event Hubs already has some of their metrics in log analytics, and log analytics can actually scale to the amount that we need. So our internal MDM system has some, like just because of the way it's built, all the things that are on top of it, it works a bit different than log analytics. But log analytics is actually that big bucket that we can push all our metrics in, and that will actually scale well enough. So that's something that we're also looking into. And what we want you to be able to do is use this in alerts. So for example, if you have one subscription that has a high message count, you should be able to be notified about that one subscription instead of what you currently have, where you will be notified about the topic. And then you have to find yourself, okay, which subscription in the topic is doing this. So we want to be able to create alerts in this, and also to add this to your dashboards. And that's where the change, the difference between the MDM system and log analytics comes. With the MDM system, we actually get nice graphs, etc., out of the box. Like that's just something that MDM system does for us. If we're going to use log analytics, this is something that you will probably need to build yourself. But you can use Custo, of course. And with Custo, you can also create nice graphs. So you can still have those graphs, but it will be a bit more work on your part. And of course, we want you to be able to autoscale subscription length. And this is actually an ask from the Azure Functions team. So what the Azure Functions team does, they look at the metrics of active messages, for example, and they scale their function, number of functions on that. However, if you have one topic with, let's say, 10 different subscriptions, and you have 10 different functions that are listening to each of those subscriptions, if one subscription has a high message count, that means that all your different functions will be autoscaling up, which of course means that you pay more than you should be doing. So that's why we want to be able to actually allow you to autoscale on the subscription length as well. And so that's what our function team is asking for, and what we also going with you. And then the final one. I would say this is an interesting one. One might say controversial one. The local emulator. This is an ask that has been put in by Jimmy Bogart on GitHub about 4 years ago with the question, what is the local development story? There is no local development story. So since then, there's been a lot of discussion going on GitHub. For those that have been reading it, you will probably have seen that it's not always the nicest discussions because people are very passionate about this. But what I want to say, we do want to build a local emulator. Like we have something that we are doing here. So what we want to give you is actually a cross-platform containerized experience for your development and test purposes. So it should be cross-platform. That's where our first challenge comes, because large parts of Service Bus at the moment are still on .NET Standard, for example. So that actually means that we have to look, are we going to rebuild this? Are we going to build something different for the emulator? But we have to actually think about how can we make this cross-platform so that you can run this on Windows, Linux, macOS, wherever you want. It also has to be containerized. So this was actually big feedback from the community, like we want to have this as a container because that means that I can run this in my pipelines, I can run this locally, wherever I want. However, Service Bus is built on Service Fabric. It's not built, for example, on AKS or something like that. Now, Service Fabric is not a container, not containers like AKS or something like that. So that also means that we have to think about how are we going to implement a runtime in containers that is close enough to our local, like our service, where we actually don't need everything that we have in our service. So Clemens Foster has a talk about how Service Bus and the Event Hubs are built up in the background with architecture. So have a look at that if you want to know more about that. But in short, Service Bus is very big. So we have to think about how are we going to put that into an emulator. And that's where we are thinking now, like, Are we actually going to use the production code and do that into emulator of some sort? Or are we just going to be API compatible? And those kind of questions is what we are thinking about. And as you can imagine, that takes some time and a lot of discussions, but we do want to give this. So it should run locally and in your test pipelines. So that's also another challenge. If you want to run this in a test pipeline in your unit test, that means that it has to be spun up in maybe 10 seconds or something like that max, because you don't want to wait 5 minutes for your unit test to complete. So it also has to be spun up very fast. There's a lot of things there as well. But we do want you to be able to run this locally, maybe as a plugin into Visual Studio Code or Visual Studio, maybe something completely standalone once again. And also from your test pipeline. So you can just say, okay, in my pipeline, just create an emulator, create the right topics and queues, run it, run my test and see what comes back. And we also have to think about what actually makes sense for dev and test. Because probably you want things like queues definitely, topics definitely, sessions most probably. But it doesn't really make sense to, for example, put something like GeoDR in there or something like autoscaling. I mean, it's a local emulator. You are using this for dev test work. And like some of them are very clear, like those definitely go in, those definitely don't go in. But then there's also this like middle part where it's like, yeah, this might make sense in some scenarios, but not for others. Like, so we have to think about what actually you're going to put in there. And also something that to think about is we have to make sure that as we go forward, we can also easily extend this. So if we release a new feature or if we update a feature, it should be immediately in the emulator as well, because otherwise you're development and testing against something that's not the same as in the cloud. So we need to keep that API compatibility. So that's why it's taking so long to actually get something out there. But do know that we are working on this, we are looking into this, and we really do want to give this to you. So with that, we're almost done. I have a few takeaways. First of all, we built for reliability and resilience. You already saw some of our features, things like GeoDR, things like the local store, things like scaling petitions. So whenever I create a feature spec or whenever I think of new feature, the first thing my development manager will ask me is, are you adhering to the 5 pillars? Or how does this impact the 5 pillars? And so the 5 pillars are stability, scalability, security, low latency, and availability. That doesn't mean that every feature has to do something for these, but if a feature does something for these, that means it goes much higher in the priority list. Because if we can make our service more scalable, more reliable, more secure, that means that we are really bringing a big impact to our customers that we really want to get out there. So that's also why you sometimes will see some features that might have been announced at some point, that then all of a sudden take a very long time. But it might just be because something like those scaling petitions came in. It's like, hey, this really has big impact on our scalability, on our stability. So we need to do this first. So we are going to put this other project on the back burner. We are continuously evolving. So we continuously try to improve our services. Once again, that's why your feedback is so important. If you run into an issue, if you think of a feature, please let us know. I actually do watch all my email, the email list. There's actually feedback out there. There's GitHub issues. And I watch all of those places, and I actually try to get all the feedback from there, so that we know what our customers are looking for. Because we want you to provide your feedback, and we listen to your feedback. Now, listening to your feedback doesn't mean that you always will get what you want, but we will definitely take it in consideration. So with that, I would like to say thank you. Here's my contact details, like on my Twitter, email, LinkedIn. Most important two though are these. So aka.ms Azure Service Bus feedback. There's the Azure IDs, or used to be called user voice. I think these days Azure IDs or Azure feedback or something like that. But definitely go there. You can put in your feature requests. You can upvote other people's feature requests. And we actually use this quite a lot with prioritization of our features. The last one is for this specific session, aka.ms Service Bus latest greatest feedback. It's the same as behind the QR code. Please take a minute or two to actually give your feedback here. General feedback about session, but also feedback about what you just saw today. Are we doing the right things? Are you missing something? Do you want to see something different? Please let us know. And with that, thank you and enjoy the rest of your day.